So today we're going to cover functions, and in order to explain it, we're back in P5 over here with function setup and function draw. And what I have is a black background, and I'm just saying strive.draw tick axes in order to get these grid lines. Now, what I want to do is I want to draw a circle inside a circle inside a circle, right? Circleception. And we'll see why I'm doing this. It's going to look cool, but we'll see why this comes into function. So let's see how we could do that. So let's just say we're going to say circle, and let's say it's going to take up the whole screen. So it'll be right in the middle, 250, 250, because our width and height is 500 by 500. And then its diameter, if our width and height is 500 and it's 250, going all the way across should be 500. So let's put that. And now we get one big circle, right? Now I want to put another circle in the middle of that circle. So I'm going to say again 250, 250. However, this time I'm going to make the width 1/3 of the original. So I'm going to say 500 over 3. And now I'm going to do that again. Let's actually make it, let's make it make it 1/2 rather, instead of 1/3. And now I want to do that again. And this time I'm going to make it 1/2 of the other circle. So let's make this 500 over 2 over 2. Right, so now we have one circle inside another circle inside another circle. And we can see that here. Let's add some color to make this look cool. Let's go like red for this one. We'll go yellow for this one. And we'll go blue for this one. Ooh, that actually looks like a sun. That looks very cool. And now it looks like a bullseye. Okay, cool. I'm a fan of that. Okay, cool. So we have a circle inside a circle inside a circle. Now, my question is, what if I wanted to do multiple of these, right? Right now I have one that's taking up the whole screen. What if I wanted to have like 10 of them going across the top and like them scattered at random places? I would need to change all of this stuff, right? If I wanted to. So then I'll need to be like, okay, if I want to put this in the top right left corner, 100, 100, now 500 is going to go way off the screen. So let's put that, I don't know, at like, let's put it at 100, and then 100, 100, and then this will be 100 over 2, and 100, 100, 100, oh, lost it there, 100 over 2. Close that. Okay, so now we have it again, and now if we want to move it around, I'm gonna have to copy paste all of this and go over and over and then change each one of these, right? So if I'm just wanting one more, for example, then I'm gonna have to change this. I'm gonna make this 200, 200, 200. And you can see how this is a little bit tedious, right? Every time, if we're wanting to keep adding it, it's going to take time. So there needs to be an easier way to do this. And that's where functions kind of come in. And what functions allow us to do is a fancy word called abstraction. It allows us to abstract all of this logic into one place. So let's see how we could do that. So I can make a function over here, right? So this, we already been making functions, function draw, function setup, but now we're going to make our own one. What I'm going to say is function circle in circle. And what this function is going to then do is it's going to take this, right? I'm going to put this inside here, and let's get rid of this for now. And I have one extra bracket, all of that, save, and then I can simply call circle inside of draw. Okay, and what is the error? Circle in circle. Okay, it just wasn't saving from that time. But there we go, right? Now we have a circle inside of the circle, and we could copy paste this multiple times. However, the problem is that they're just going to be drawn on top of one another, right? Because all of them are just taking the same points. What we can do is we can pass arguments into the function. We can give it numbers and then change these accordingly. So the way you give arguments into a function is inside of these brackets, you specify them, right? So I can say x and y. Now these are variables that I have access to inside circle and circle. And what I can do now is instead of saying 200, 100, I can say x, y, x, y, x, y. And now with circle and circle, I have to give it those numbers. So let's say this one, I'm going to put a 100, 100. This one, I'm going to put a 200, 200. This one, I'm going to put a 300, 300. Okay, perfect. And now you can see how each one, right, it's taking these numbers as their x and y. For every time it calls, it kind of copy pastes this code over here, and it uses 100, 100 as x and y. And you can see how much nicer and simpler this now is to create multiple of these. We could take this one step further. What if we wanted to control the width, or the diameter rather? We can pass in another argument. So I can pass in diameter. And now over here, I can simply use diameter as the variable. So I'm going to say diameter over 2 and diameter over 2 over 2. Now I need to pass that in. So let's say this diameter is 100, this diameter is 200, this diameter is 300. And now you'll see them all grow in size, which is pretty cool, right? It's a lot of power we've now been able to give this, and we've made our code far more readable and far more understandable in the process. So this is one form of function. Quickly, a mistake I see a lot of people make, this only thing in P5, is that they'll try to put circle and circle outside of draw. It won't work. You need to put, if you're calling these commands, like circle and fill, only P5 knows what to do with them, right? Regular JavaScript doesn't. And P5 is looking for these commands inside of draw. So it means that you have to put these commands inside of draw or inside of setup. That's the only time P5 will be able to actually recognize the commands like fill and circle. Okay, so that's one type of function, right? That just allows us to kind of repeat logic. It's another type of function that allows us to return a value, and you'll see why that's useful. So let's say I wanted to, let's actually, before I even jump into the function, let's say I wanted to work out the area of these circles, right? So we know that the area of a circle is pi times by the radius squared, right? That's the formula for an area of a circle. So I know I can maybe say, okay, let A1, so I'm wondering the area of this first circle, I know that's going to be equal to pi. I think we have access to pi just here. Otherwise, I know math.pi will work, right? So math.pi will give us 3.14, the value of pi. And then we can say the radius. Now this is diameter, so it's going to be 50, right? Or 100 over 2, right? We can maybe do that, 100 over 2. And all of that squared. That will be then the area of the circle. We could print that to the screen, or let's rather put it in text. So otherwise it's going to go, so we can say A1, and let's put that at like 450 or 100, 450. And we should, it's going to by default have a black background. Oh, there we go, cool. Okay, so we can see it over there. So that is the area of this circle. Now we need to repeat this for each one, right? And now we're repeating the logic over. So now for this one, I need to put 300, and then for the, can't make it A1, I need to make this A2, etc., right? So there's a similar thing here where we're reusing this logic. And what we could do is we could actually put this logic inside a function, and we can return that value. So the way we do that is the following. I'm going to make a function over here, and I'm just going to call it area. And let's call it area of circle. And the argument it takes is its radius. And what it does is it then says return the math.pi times by the radius squared. The way we do squared is we just do 2 asterisks, does a square. So now we give it this value radius. This function calculates what it is, and it throws it back. It gives it back to us. That's what return does. We're not returning anything here, so we're not throwing anything back. I'll show you what we mean by that. So instead of saying A1 is equal to math.pi of this, I can say A1 is equal to area of circle, and I can simply pass in our, notice we're using radius here, and this is diameter, so I need to put 100 over 2. And then I can do the same for each one of these. Let A2 is equal to area of circle, and I can say 300 over 2. So So you can see how I'm able to now reuse this logic, and it's easier to read than if I were to put math.pi times by radius squared. This, if somehow someone doesn't know how to calculate the area of the circle, they can clearly see, okay, this is calculating the area of a circle. I know what this does. So it makes the code very readable. Now, we wouldn't, if we weren't returning anything, we wouldn't be able to say this, because when we're saying return, we're saying, okay, call this function, and whatever value comes out of it, put it into A3. But if we were to make a variable for, like, I don't know, whatever, like let's call it Bob, and we make it equal to circle and circle, we're not going to get anything. We could try. Let's actually see what happens. I imagine we might get an error, or we're going to get something like undefined. Because circle and circle doesn't return anything. So saying something is equal to circle and circle, even though it's doing something, right? So it can have side effects in the sense of it does stuff to the screen. But because it doesn't return anything, it doesn't mean anything. It doesn't actually work. Let's see what we get. Yes, we get undefined, right? So this console.log over here is coming from all of those bobs, right? Because we're not returning anything. If I return something, return 1, it doesn't make sense. Notice now, inside of console, we will be getting 1, right? Because that now we're console.log and bob, and we're returning 1 each time from it. So that is functions. Can have regular functions that don't return anything or functions that do. And if we're calling particular functions relative or specialized to P5, they have to be inside of draw. I'll end this video here. Awesome stuff.